Hi. Today I would like to explain something. I did some research and looks like it could be a great concept of protecting cloud deployment, especially the NCI/CD pipeline using GitHub Actions. GitHub recently, last year, I think they launched something, a built-in OIDC provider. That means it has an OpenID Connect provider itself. Now we know. Let's step back. So when we try to deploy any cloud resource, what happens is that we need some sort of service principal account, and when we need that service principal account, that is basically, what's happening is that's ideally it's an identity management problem. It's basically related to authentication and authorization, but because we need to generate some secrets, it turned into a secret management problem, and we need to basically make sure we manage the secret somewhere in the vault or in the GitHub secrets, and make sure. But there is also problem with rotating secrets, because secrets has an expiration date. You need to manage that. So this is kind of another cross-cutting problem, and again creating a security. You're increasing your attack surface for your security concern. So there is a great solution, I think, which came up, which is called workflow identity federation, and I did some research on that, and I found it could be an awesome concept. But Google has started the support, I think, from the last year in GCP. Microsoft, it's in preview mode, but it's been supported through Azure Ready apps registration. So I'll show you a demo how it needs to be implemented, and I'll go through the flow. But there are problems like the Terraform, Ansible. They are still not supporting it out of the box. Terraform is very close to support it in the, I think, in the next version or later, according to their GitHub issue page. But it's still not yet supported, but it's only supported when you use the native Azure ARM, or you use the GCP native CLI, or the GSM or Azure CLI. So let's understand how this works. Okay, so I have implemented this, so you can visit this GitHub repo URL, and I'll share this link with this YouTube video also. But and I have created a very good README page. You can go through and understand. So let's understand the flow. Okay, how it works. So basically, when we need it, when you wanted to access your cloud resources from outside of the cloud, right? So basically, when you deploy your CI/CD workflow, or you integrate between your on-prem to cloud, or some application from on-prem to cloud or cloud to cloud, you need some sort of credentials to be shared, and that's typically a service account, because that's not a human thing, right? And that's why we talked about the secret management. But how you can, without sharing any secrets, and you just, without any long lived secrets, you just have issue a short lived token, like typically what happens in human identity and authorization flow, using OID and OIDC flow, or OpenID Connect, and OAuth and OpenID Connect flow. So this is how it works, right? So you have some external application or workload. They basically request an token. So in this case, the GitHub is providing a built-in YDC provider. So it's GitHub is providing its own token, and the token is being sent to that application. In this case, it's going to be GitHub Action Workflow, and then the GitHub Action Workflow is basically send that token to an app in which is registered in Azure Ready. So you have to basically, if it is this example is mostly for the is example for the Azure. So you have to register. You go to the Active Azure Ready, and you have to register an app, and then you need to actually configure your federated identity in as a secrets and credentials, and then basically you need to I'll go through those commands. So basically you have an app, so they sends those token and requests those and the access token. So what then the Azure AD does is basically checks back with GitHub whether the token is valid or not, and if there is a trust established. And I'll come to that trust part when we will see actually how when we register it. So there has to be a trust established between Azure AD app and your GitHub um, OIDC provider, and trust is then actually Azure AD will issue a short-lived access token, and that's what will be used for authentication and authorization purpose for that workflow. And it's only very short-lived token. Typically what happens in login in any web app, it's a short-lived token, and there is no secrets to be managed. And once the workflow gets that short-lived token, it uses that short-lived token and access the protected cloud resources. Like if you use it for infrastructure as a code, you can create any resources or update it based on the type of access it has, and it can be controlled at all levels. Now I'll show you how it can be done. Basically, the so you can visit this, but typically there are four steps, very important four steps. So before you can configure this, you basically need to create an app in Azure AD using CLI command. Then you have to create a corresponding service principal account for it. That should be the same app ID as the service principal account ID should be the same as the app ID. And then you basically do a GeoReady role assignment, and you can assign whatever the role you want to that, like so. And here, well, here you have to provide the subscription ID and the object ID you received from the step 2. And you basically so you can, the one important thing is I'm given here a contributor role, but you can give whatever the granular role you want, and it's recommended to provide as granular role as possible following the least privilege security practice, best practice. So then basically once you get that, you basically make a REST API call, and that's where the trust is being established. And this is a very important thing, where if you look into this payload carefully, I'm passing, this is basically the token endpoint, where the token Azure will be called to get that token, verify that token. And then basically this is a like a repo URL. I have created a test organization called Digital Code Science, and then it has a repo here. And then I have configured an environment, though it's for Terraform apply. I just but it Terraform, one call out is it's not yet supported in Terraform in current version, but it's being planned to support in the in very near future. And there is already an issue being tracked. I'll update that into the YouTube link as well with this video. So okay, enough theory. Let's see the action. So I'll show you the workflow code first. So the workflow code is very simple. You basically you just, this is a workflow dispatch. That means you have to manually trigger it. You just give an environment name, environment type, which you use for tagging, and I'm using West US. I have some self-hosted runner configured to do this. So, and there's a tagging in the environment, and I'm just saying it will be run on the main branch only. So the important here is that you see this step where so you need to basically need these three things as a secret to configure, but these are not really actually the client secret, right? You need to have the client ID, the client's in the tenant ID, and the subscription ID. That information is very much important. And then it basically, you need to, as I showed you earlier, that you need to configure the OIDC. When you configure the app, you need to say at what level. It's a branch level or tag level, or it's an environment level. I have used the environment and use the environment information out there. And then basically it just checks the, I'm using, I have configured the code to dynamically create a resource group. So it's just getting dynamically resource group name, and it's basically using the CLI. It's creating the resource group, and I'm just seeing if the resource group is successful or not. So let's run it. So I'll go here and I will run this workflow, and this workflow is protected. So it will expect an approval from me only, but just to make sure that um, by any chance I don't run it by mistake. So a new workflow is created. Let me review it. Okay, it started. Okay, awesome. So you see, it if you see that it's this is the CLI. It first actually check out the code, and then it did that in the OpenID connect. It got the token from here, and then login is successful with the short-lived token. And I just check the current directory part, and then it's basically the create flow. It's created the resource group, and I checked with the command whether resource group is successfully created or not, and I see yes, resource group is successfully created. I use a dynamic name, and that's all. Hope you can refer to the code. It's out here in the public repo. Feel free to fork it and play around. This is a great feature provided by GitHub and GitHub Actions, and I'm sure this is going to be the future where we're going to ditch the service principal account and adopt a passwordless uh, workload identity federation. And just to show the same thing, we also have for GCP, Workload Identity Federation, and it's more easier there in GCP. And I'll have a demo for GCP very soon. I'll show you how you can implement in GCP as well. So stay tuned for the next video. And feel free to subscribe to my YouTube channel and ask me any question. As long as it's not something with conflict of interest or confidential, I'll be happy to answer for knowledge purpose. Thank you. Bye.